Okay, I have a short video that's going to kind of introduce our next topic, our Unit 4 in this unit. It's about functions. And so first let me give you a basic idea of what a function is. We can kind of imagine a function to be like a little box or machine that changes numbers. And this function that I have is 2x plus 1. So if I were to throw a number into my box, such as 3, out would pop a 7. It would change that 3 into a 7 because 2 times 3 is 6, plus 1 is 7. If I were to throw a 5 into this box, out would pop in 11, because 2 times 5 is 10, plus 1 is 11. These values that I'm throwing into my box over here, these are my x values, or in other words, my input values. And over here are my y values, or in other words, my output values. Something else you may hear this called is the independent variable and the dependent variable. And the reason for that is whatever thing that pops out depends on what you throw into the box, obviously. If I throw a different number into my box, it's going to change what number pops out. And so, if I know a function like this, and I know what my x values are, I can use that function to find out what my y values or my output values are. Now, let's move to a different example. Let's say we have another box, and we don't know the pattern on it, okay? We don't know that it's 2x plus 1 or whatever it is. So let's just start throwing some numbers into it. Let's see, if I throw a 15 in, out comes a negative 30. If I throw a 5 in, out comes a negative 10. And if I throw a negative 2 into my box, out pops a positive 6. Well, if I look at my input-output values, I can probably make a pretty good guess at what the function is. I'm looking at it, it looks like they're doubling. It looks like it's the opposite of twice whatever my x value is, or in other words, y equals negative 2x. Because negative 2 times 15 is negative 30, negative 2 times 5 is negative 10, and negative 2, whoops, I messed up. And negative 2 times negative 2 is a positive 4. Okay? Now, so I've given you two situations. One is where I give you the input values in the function. You can predict the output values. If I give you both the input and the output values, you can make a pretty good guess at what a function is. But the thing is, not all of our functions are nice little easy equations or expressions like this. Sometimes they can get nasty. And I've got this example, x cubed plus x squared minus 1.32x minus 2. Well, if we looked at the x values and the y values, or in other words, the input and the output values from that function, I don't know about you, but if I was looking at that, I wouldn't be able to predict this equation right here. So what we need is we need a way to be able to tell if a relationship is a function without being able to see the specific pattern, because some of them get really complicated like this. And here's the basic idea behind that. The basic idea is that for every x, or in other words, for every input value, I should have only one y, or in other words, output value. And let me explain what I mean by that. If I've got a box, and I'm not sure if this relation is a function, and I throw in the number 5, out pops let's say a 22. And if I throw a 3 in, and out pops a 7. And I throw, let's say I go back and throw another 5 in, I should expect a 22 to pop out again. But let's say something different pops out, like a 15. That means this is not a function, because the same x value has two different y values. Okay? So like I said, every x can have only one y value. Let me make it look a little bit different. If I gave it to you as a table, and let's say I threw in a negative 1, a 5, a 7, and a negative 1 again. Let's say the first time I threw in a negative 1, I got a 5. When I threw in a 5, I got a 29. I threw in the 7, and I got a negative 4. And I threw in the negative 1, and I got a 5 again. This would be a function, because whenever I input a negative 1, my y is a 5. There's no contradictions here. But let's say the second time I threw in a negative 1, out popped a 42. Well, then that would make it not a function because the same x value has multiple y values. So like I said, I don't know if you can identify a pattern in these numbers. I can't. I really just made the numbers up, but you might see a relation like this where you can't identify what the pattern is. Okay? But even so, I can still tell if it's a function or not by making sure that every x value has only one y value. Now, let's look at the opposite of that statement. So I've given you two examples here. Here we have a relation. Let's look at this first. When I put in a 3, I get a 2. When I put in a 4, I get a 7. When I put in a 3, I get an 11. And we've established this would not be a function because the x value of the 3 has multiple y values. Now let's look at the opposite over here. Negative 2 has a y value of 4, 1 has a y value of 1, and 2 has a y value of 4. Well, different x's are now giving us the same y value. I wonder if that can happen. Actually, this is just the function of y equals x squared. Whenever I put a negative 2 in for x, negative 2 squared, or in other words, negative 2 times negative 2 is positive 4. And whenever I put 2 in for x, 2 squared, or 2 times 2 is positive 4. This is a function. Two different x's can share the same y value, but the same x cannot have different y values. And I know that's confusing. Let's look at one last example, and here's another way that you might see this. I'll give you two more ways. Let's say I have negative 3, 4, 5, 7. And then my output values are 2, 11, 15, 47, and 5. If I throw in a 3, my output is a 2. If I throw in a 4, my output is an 11. If I throw in a 5, my output is 15. If I throw a 5 in again, my output is 47. And if I throw a 7 in, my output is 5. As you can see, this is not a function. So if I put the 5 in once, I get a 15. If I put the 5 in again, I get a 47. I can explain the same idea. You're going to see the same type of problem with different representations. You might see it as ordered pairs. If I've got the ordered pairs like this, I know that the first number of my ordered pair is the x, the second is my y. Or in other words, the x is my input, and the y is my output. So 3, 5, 4, 7, 5, 11. I'm just making up numbers right now. Let's say if I had this, right now this is a function because every x has only one y value. But let's say you find out that 4 also has a y value of 14. Now it's not a function because the same x value has different y values. I know I've thrown a lot at you, but here's the main idea from this video. Every x value has only one y value. Every independent variable has only one dependent variable that goes with it. And every input has only one output. Watch my other videos. I'll have other videos and other resources posted in NetSchool. Come to tutorials if you need help.